If you have been following the tech stuff on social media, then definitely you must have come across some of the related videos where the kind of constructive or the beautiful ceilings have been getting applied onto the building apartments. So how it is happening means the whole floor settings and all the coloring, the placing of the objects, etc. Everything gets applied to a specific apartment of a building automatically. And this is done just to give the user a kind of idea that how specifically a apartment is gonna look after getting fully furnished. So these sort of things are quite common nowadays in AI era. Especially these things are getting possible with the help of models which are working behind the scene. But have you seen some of the related things with respect to data sets? So in this particular video, we are going to talk about such related data set named ScanNet. So let's start. Hey there, my name is Rohit Kumar, and today we are going to talk about a richly annotated 3D reconstructions based indoor scenes based dataset called ScanNet. So here we are at the homepage of the dataset, and here you can see that these are the kind of contributors, the kind of original authors from the Stanford University, Princeton University, and the Technical University of New York. So quite a collaborative work, and you can see that here they have given the benchmark challenge also. So if you're interested, you can go and have a look onto this. Some of the related news with respect to the timelines they have given over here with respect to the ScanNet version releases with the respect to the 2018 June, they have released the version 2 of ScanNet. Coming on to the specific introduction part, so they are claiming that they have 2.5 million views from more than 1,500 scans, and the annotated 3D camera poses, surface constructions, and the instance level semantic segmentations have been introduced. So to collect this data, they have used the different sort of approaches, including the scalable RGBD capture system, where they have used the automated surface reconstruction and the crowdsourced semantic specific thing. Then moving on to the specific work, here we have the Cornell University Archive website. So at Archive, we have this particular paper, which is supposed to be the base paper with respect to this particular data set. And here, as I told you, that if you're interested, you can go on to looking into the specific key details. So just go to the PDF and you will find a lot more information. Meanwhile, it gets loaded. We jump onto the specific one related GitHub repository, which is related to this particular dataset. How specifically it is related, that they have used the kind of key parts with respect to this particular dataset. So in Atlas, they have used the end-to-end 3D scene reconstruction from posed images, and as you can see that with respect to the specific camera, they are creating the scenes automatically. So here, end-to-end 3D scene reconstructions is getting happen. So it's quite wonderful to see these sort of videos, because usually we come across the AR or VR related possibilities, but those possibilities gets realized with the help of these sort of algorithms and the box. So when you, as you are seeing that it might be looking too slow or the kind of bit slow in comparison to the works that you see in videos available on YouTube, but just think about it, the powerful hardware, the more specific and the specialized models, the kind of training your models are having, all these things are together put power to the specific work. So that's why don't get kind of astonished when you see a very impeccable kind of model or a very basic kind of model, because both things are kind of related, but means interrelated. It is not always possible that you are designing a sophisticated model without having the basic understanding. So first you need the basic understanding of the basic works like this, and then you make it a sort of improvement and improvement means different versions of improvements over the period of time, and then you land on to us sophisticated models of the fully furnished video software. So a quick start guide they have given over here with respect to Colab Notebook, and Colab is a very popular platform with respect to constructive laboratory work. So if you are going for the collaborative work, then Colab becomes a favorite choice. Then the installation related information with respect to Panda and the related dependencies they have given over here. So with respect to pip install, all the dependencies are going to get installed. Then you can do your work. The data preparation with respect to ScanNet and the sort of inferences, evaluation, training, etc., etc. All the information are given over here. And don't forget to give the due citation, because it's always difficult to contribute to the original authors, and that's the basic bottom line of research. So that's the thing. Now moving on to the specific base paper as we were talking about. So it's a 2017 work which is published on Archive. And then in this work you may get the basic introduction of RGB-D sensors. So then you have the different sorts of data sets, their sizes, labels, and the annotation tools which have been used in the past. Then the previous works I have discussed the kind of data sets related settings and the surface area related settings. Then the ScanNet dataset they have discussed over here, the kind of parameters and the different sorts of things that you can do with the datasets. All these things are discussed. Then they discussed their own results with respect to the specific fixation of different floors, walls, chairs, and the different sorts of objects in the apartment. And then with respect to different classes of objects, they have tested the specific accuracy. So that's all from this particular work. Hope you must have liked the video. If you didn't like anything, please do comment and let us know what are the sort of things which can be included. We'll definitely try to incorporate sort of things. Thanks for watching. Have a